Hey everyone, welcome to another Operate First Data Science Community Meetup. Today we have Oleg Silkin from the platform team in the Emerging Technologies group. He's going to give an overview about his latest project called Copilot-ops. So over to you, Oleg.
Thanks, Akanksha. So let me share the screen. Hey, everyone. So as Akanksha has mentioned, my name is Oleg Silkin. I'm an associate software engineer on the platform team in Emerging Technologies. And by the end of this talk, you'll learn about how you can use copilot-ops to go from zero to DevOps hero in under 10 seconds. You'll also walk away knowing a bit about generative transformers and how they can shape the future of the Operate First apps repository. So let's get into it. The first thing we're going to talk about is application deployment. So modern application deployment happens through Kubernetes or OpenShift. If you're using Operate First, you're going to be using some Operate First cluster. And typically, you'll have to depict various YAMLs, which describe the nature of your application and the various components that you're going to be using. And a lot of the structure of the YAMLs tends to be pretty repetitive, but not in a way that's easily templatable across various projects, but in a way that have to sort of maintain prior records of YAMLs if you want to make your life easy. So here's an example of a MySQL deployment that I pulled from the apps repo. So this deployment uses a PVC titled MySQL PV claim. And that PVC is a dependency in the MySQL deployment YAML. And that YAML is then referenced by MySQL service, which exposes the various pods that are created by this deployment. Now, if you're anything like me, you're probably looking at these and kind of squinting your eyes a little bit because there are so many various components to take in that it can be overwhelming. And that is where we will start to implement it. So if you want to implement this deployment, you would first create a PVC deployment YAML. And the very first line, you'd write API version apps v1. Then we're going to specify the kind of deployment. And then we, of course, have to specify the metadata, which in this case is going to be MySQL-deployment. Then we have to put the spec. So we're going to start writing the selector, and we're going to tell it to match labels. But hold on a second. This is a bit overwhelming. Is there any way that we could make this a little bit easier? Well, that's where you can get some help from transformers. And we're not talking about the kinds that turn into cars or try to kill you, but specifically generative transformers. Now, this is a broad range of various models, but we're specifically going to be talking about GPT-3, which is a model released by OpenAI, and they expose it through a not public API, it's private, but it's a paid API. And essentially, they have a 175 billion parameter model, which uses various mechanisms in order to actually do sequence to sequence translation. And we're not going to go into the details here, but specifically, we're going to be worrying about their Codex model. And Codex is a trained model or a trained variant of GPT-3, which was using a custom tokenizer, which specifically targets code and training on a corpus of GitHub data. They were able to train GPT-3 in order to actually generate. And the way this works is it's context-based. So here is an example of a React app, or the start of one. And the reason we know this is a React app as humans is we read the first line here, which is import React from React. Then we have this comment here, which is a JavaScript style comment, talking about how it displays a list of to-do items. And we again mention that this is a React app. And on the fourth line, we say const app equals props, and then we do some common JavaScript syntax. Now, based on this, GPT-3 is pretty amazing because it's able to generate the start of a React app pretty well, like this. And these are a lot of details that we normally have to write out by hand. But thankfully, with GPT-3, we don't. So can we go YAML mode with this? Well, it turns out we can. So here we have an example of a YAML, and we know this to be a YAML because first off, this is a comment, but this comment isn't unique to YAML. It could be a Python YAML or Python file. It could be bash. So we don't really know, but we read this and it says create a Kubernetes MySQL deployment using MySQL version 5.7. Up to this point, this could still be bash, Python, or other languages that use the same lex for comments. But the reason we know that this is a YAML is the next object, which is kind::deployment, which is a common YAML syntax. And based on this context alone, GPT-3 is able to generate almost complete YAML. Well, it is complete. I've just truncated it for visibility, just based on this little context alone. So going back to our YAML spaghetti code, can we actually use GPT-3 in order to generate all this? Well, that's where we're going to do a demo. So I'm going to reshare into VS Code. Give me 1 second. Let me make this a little bit bigger. So right now we're in the copilot-ops repo, and I have a binary that I built here just before starting the presentation. So the first thing we'll want to do is generate a PVC. I've already typed that in, so we can just run this. But what this will do is it'll contact using some information with OpenAI and create a YAML, and it'll write that into generated by copilot-ops, which is just a templated repository. So we'll open this file up and we'll split it. We'll just split this right. So we'll be using this. So over here, we see that we actually have a persistent volume claim. Now, it's not perfect. And as we can see here, there's this little comment. So we could just go ahead and delete this. It also threw in some access modes. We can just get rid of that because we don't need that. It says storage class name manual. We'll get rid of that as well. And here we see a pretty basic PVC. So we'll go ahead and save our changes. And what we can do is we can rename this copilot-ops, or we can rename this generated file. So we'll do mv generated by copilot-ops, and then we'll do that again. And then we'll call it generated by copilot-ops pvc.yaml. So then I'll clear our screen, we'll close this out. And now what we can do is we can run copilot-ops again, but this time we can ask for it to generate a deployment. And we'll say, create a deployment that launches 2 replicas of a MySQL 5.7 image. And we'll say, and uses at pvc.yaml as a storage volume. And then we'll bring that file in with file, and we'll say generated by copilot-ops, and we'll tell it where to find it. So we'll do pvc.yaml. And this is a lot of logs that I didn't actually clean out. So at the moment, I did specify the right flag, so it just wrote it to standard out. But we can go ahead and copy this, or we could just do -right. Either way, doesn't matter. We'll rerun it. Then once it's done generating the file, it will put it back into this generated by copilot-ops file. And we see here, we actually have a pretty thorough deployment. Now, it's complaining about something. Oh, resource limits. Okay, we don't really care about that. So what we can do is we can just rename this file. So we'll say generated by copilot-ops, and it's going to be that generated by copilot-ops YAML, and then we'll call this deployment.yaml. So now the next thing we want to do is actually create a service that exposes this. So we'll just do copilot-ops again. I'll say generate, and then we'll request create a service to expose the pods created by that deployment.yaml. And then we'll just specify that again. So we'll say file generated by copilot-ops, and then we'll say deployment.yaml. And sometimes it's not perfect, so I'll just run it again. Looks like it wrote something, so let's see what it made. Yeah, here we go. Minus this little like character here, this is a pretty good service. So we can just go ahead and save that. And we can rename that to copilot-ops service.yaml. And it can do other things as well. So it can also edit files. So if we want to rename the service, we can just say copilot-ops edit. We'll request it again. We'll say rename at service.yaml to MySQL service backup. And we will just specify that file again. So we'll do file generated by copilot-ops service.yaml. And we'll say write to it. So it'll just write directly to the file. And let's see what our result is. So we'll go to service. So it called it MySQL service. It's not always perfect, so we could just rerun this again. Looks like it's complaining about not finding a tag name. Now it's complaining about not being able to find it.
I think you spelled YAML wrong when you were writing that command. I think that's why it's giving an error.
Oh, yeah. Thank you. I did not see that. All right, now it's not working again. So it's not perfect, and that is a flaw, but I will show you how this can be handled in the operate first repo. So can I get this to work? No. That needs to be worked on a bit more. So this is a very early version, and we are planning to fix a lot of this. So going back to the presentation, so I'll stop sharing this. And I will reshare the other window. So going back to our question, can GPT-3 solve this? Almost. There are some touch-ups that we'll need to make because it is only working on a certain amount of data. If we wanted to have it generated specifically, we would just need to run multiple iterations, or we can do minor touch-ups ourselves. But it's not telepathic, so we can't tell it to generate exactly this file. Otherwise, we just have to write the file ourselves. So it's a little bit paradoxical in that way. But if you don't have an existing file, this is really quick. So let's go into how it can improve. So there's something called fine-tuning, which is essentially training, but through OpenAI's API. And what you do is you generate a bunch of files and you say like, okay, this is the input and I want this desired output. So doing that for the YAMLs will yield in better accuracy overall, and it'll be closer to what we want. The other thing is clever prompt engineering. So a lot of generative models or generative transformers rely on context. And the way that you word things, as we saw with the React example, tends to change what is generated. And if you word it specifically in a way so that it gets you what you want, then you'll also have better accuracy overall. So this is something that you need to just continue iterating on. Now, we're going to talk about the vision for copilot-ops with respect to operate first. So we vision a future where you can go to the operate first apps repository. And let's say you want to touch up the PVC files that we mentioned earlier. So you'd go to requests, and then, or you'd go to issues, and then you'd create a new issue, and you'd say like update MySQL deployment. And there would be a template that would be provided for you, and it would look something like this. You'd reference your files, you'd describe your changes, and then you'd create that new issue. And then the copilot-ops bot, let's pretend that's not actually my profile, would actually create a PR mentioning the issue. and then you'd go to it, and it would actually edit the file or generate, depending on which it is, with the appropriate changes. Now here we see that my original request was to update the deployment to use MySQL persistent storage backup as storage. Here, it did that, but it also renamed this label to be MySQL backup. We didn't really want that, so we can just say, like, revert this on a comment in the PR, and then the bot would see that, and it would pull that out and revert that change, leaving us with the desired outcome. That has been Copilot-ops. If you are interested in learning more about the project, you can check us out at redhat.at/Copilot-ops. The project link is here. And now we can answer questions.
Awesome. Thank you so much, Oleg, for this great presentation. And I'll open the floor for questions if anybody has any.
Okay, great. Yes, Karan?
Yeah, so that was an awesome presentation. Thanks for that, Oleg. So I was wondering, so you said the fine-tuning part is still on the to-do list, right? So whatever performance that you showed in the demo, was that something we were able to get out of the box from the GPT-3 Codex, or
Yeah.
was there? Okay.
Yeah, so they haven't released fine-tuning for Codex yet. They said that they're planning to release it soon. And so once that comes, we would simply just fine-tune it with the desired data, and it should yield better performance. But yeah, this has all been out of the box.
Cool, cool, awesome, thanks.
Yeah, great question.
I had a quick question. If I wanted to use this Oleg, I mean, do I need to get my own Codex like API token, or is it available through the work that you're doing? Like, how could I go ahead and use this before it's implemented as part of a GitHub bot?
Yeah, so we have an organizational account at the moment, and I would have to provision an API key for you, but I can happily do that after the call.
Sure. Has the Operate First or any other community like actually implemented a deployment using this method yet?
Not yet. We are working on getting it improved, and we will be implementing it as a bot shortly.
Cool. It's exciting.
Thank you.
I've got a question. Is YAML like one of the languages that GPT-3 has been trained on specifically, or was it kind of like a new set of inputs for that model, or what do you know about that?
Yeah, so YAML was included as part of the GPT-3 training data. I think both for GPT-3 as well as Codex. But I'm not sure. I mean, it's able to generate Kubernetes YAMLs, and it's able to understand what we mean when we talk about Kubernetes things. Maybe not always in an OpenShift specific context, but Kubernetes, like as a whole, is pretty covered by Codex.
Is that just because of all they found a bunch of YAML files in the corpus of things on GitHub? Is that the reason why?
Yeah, so when training it, I believe they needed to actually annotate each file and like say, so line by line, I think they actually had to like tell the model what it needed to know, like with some extra info. So I would imagine that if it works on YAML files, then they probably did some extra work to train it. But great question.
I have a quick question. Is this being used currently in are developers currently using it, or is it still in like a research phase and it's being developed further?
So yes and no. This isn't being used mainly, but we did have an OpenShift developer start using it, and I think he showed it to his team, and they found it to be useful, but obviously they ran into bugs because it's not perfect, and that's where we would like more help with.
Okay, thank you.
Yeah, I just wanted to return to the fine-tuning question again quickly. I mean, yeah, is it because you're specifically looking at like OpenShift YAMLs that you want to like stuff more of those into the last few layers?
Yeah. So yeah, great question. So with OpenShift in particular, and with Kubernetes as well, you will tend to have custom resources that it might not know of ahead of time. And if documentation changes, then if you trained on like, I don't know, Kubernetes, if you had all the custom resources in 2019 and you trained on those, well, if there were API updates, then you wouldn't actually know about those. So fine-tuning allows you to handle those changes and give it better context. One of the tricks that OpenAI has also released was if you wanted to have some extra context about what it should be generating, then what you could do is you can provide it with an empty prompt, like you don't say anything, and then in the output, you would give it like information about what you're doing. So if we wanted to fine tune it for our case, we would have some empty outputs and we just have like some operate first, like OpenShift specific YAMLs that it should be generating. And that would kind of tell the model like, hey, this is what you want to be looking at as a baseline.
Okay, cool. That seems clever.
All right. Thank you so much, everyone, for joining us for another meetup. And thank you so much, Oleg, for signing up to give a great presentation today. And see you all in another 2 weeks. And have a great day, everyone.
Thanks.
Thank
Good to be
you.
here. See you.